Hi guys, welcome to this video tutorial where we'll be looking at further problems on the highest common factor and the lowest common multiple and learning some new ways of approaching some of these problems. So let's go ahead and have a look at the first question. Light A flashes every 50 seconds, light B flashes every 30 seconds, light C flashes every 15 seconds. All three lights flash at the same time. Work out how long it will take for all three lights to flash at the same time again. So if you'd like, pause the video and have a go at this question, and when you come back, we'll have a look at the solution. Welcome back. Now, there are different lights flashing at different times. Light A will flash every 50 seconds, light B will flash every 30 seconds, and light C will flash every 15 seconds. Now, another way you could look at this is that the time at which light A will flash will be at a multiple of 50. The time at which light B will flash will be at a multiple of 30. And the time at which light C will flash will be at a multiple of 15. So there will actually be several times at which these three light bulbs flash at the same time. And we can find that by finding a common multiple between these values. But we've initially been told that all three lights flash at the same time. And as we've been asked to find how long it would take for the lights to flash at the same time again, we need to find the lowest common multiple between these values, which will give us the first time or the next point at which they flash at the same time again. One way we could do this is by writing a list of multiples for each value. And from this list, you should be able to see that 150 is the first common multiple of each term. And so it will take 150 seconds for all three lights to flash at the same time again. Alright, now you could have done the prime factorizations of these values and then used Venn diagrams to find the lowest common multiple, but I looked at the numbers and I could see that the numbers ended in a 0 and 5. So I assumed that using multiples would be easier and perhaps quicker to work with in this case. So I'd always recommend that you have a look at the values in the set of numbers before you choose a particular method. Let's have a look at the next question. Here we've been given two values, A and B, which have been written as a product of prime factors raised to indices. And we've been asked to find the highest common factor and the lowest common multiple of A and B. So I'm going to give you a few moments to pause the video to have a go at this question. And when you come back, we'll have a look at the solution. Welcome back, and I hope you had a decent attempt at that question. Now, in order to calculate the HCF and the LCM of A and B, we could certainly use the Venn diagram method by writing all the distinct and common primes inside the Venn diagram and then using the Venn diagram to calculate these values. However, I'd like to draw your attention to a slightly different method that also requires you to find the distinct and common prime factors. But instead of using Venn diagrams, you're directly taking numbers out of these prime factorizations. This method can be extremely useful when you're given prime factorizations with powers or indices involved. Okay? So starting with the HCF, what we need to do is take the matching base terms or primes between the two values. And in this case, we can see that the common primes are 3 and 7. Start by writing these as a product. Okay? And from the prime numbers we've taken, we then need to choose the lowest power out of the two values. So the lowest power of 3 out of the terms A and B is 1, and the lowest power of 7 out of the terms A and B is 3. And so 3 to the power of 1 multiplied by 7 to the power of 3 is equal to 1029. Okay, so the HCF of A and B is 1029. So to find the HCF of a given set of values which are written as a product of primes with powers, just remember matching terms and lowest powers. Now, in order to find the lowest common multiple, we first need to find the distinct prime factors between the two values. Okay, and the distinct prime factors are 2, 3, 5, and 7. Okay, and you also write these as a product. Now, instead of choosing the lowest powers for these primes, we need to choose the highest powers for these primes. Okay, so the highest power of 2 out of these prime factors is of course 3, as 2 is the only prime factor. The highest power of 3 out of these prime factors is 5, as 5 is of course greater than 1. Here 5 is the only term, and therefore the highest power is 1. And out of these two 7s, the highest power is 4. And when we multiply this together, we get a solution of 23,337,720. So for the LCM, just remember distinct terms and highest powers. And as mentioned, you can still use the Venn diagram method and check your answer. So let's have a look at the next question. Here we're given values A, B, and C. And the question says, given that the highest common factor of B and C is 2 to the power of 3 times by 7, and the lowest common multiple of A and C is 2 to the power of 4 times 3 to the power of 5 times 5 squared times 7 to the power of 3. Find the value of P, Q, and R. So I'm going to give you a few seconds to pause the video, have a decent attempt to this question. When you come back, we'll have a look at the solution. Now let's discuss the solution. So here we're given the values of A, B, and C, which have been written as a product of primes with indices or powers. And one of the things we're given is that the highest common factor of B and C is 2 to the power of 3 times by 7. Now in the previous question we discussed that when given values of this form, what you need to do is you first of all need to find the matching prime factors and then choose the lowest powers. Okay, so looking at B and C, we can clearly see that the matching prime factors are indeed 2 and 7, which you can see as the prime factors given here. Now, the power of 7 here is 1, as you should know, okay? And as we would choose the lowest power, since 1 is less than 4, that tells us that R is equal to 1. Now we're given that the lowest common multiple of A and C is as follows. So here are the values of A and C, and the lowest common multiple based from these values would be written as follows, using our method of writing all the distinct prime factors and all the highest powers. Now P is clearly the highest power of 2 because there are no other 2's to compare this with between A and C. Now we can't quite tell whether Q is going to be greater than or equal to 1. But since we've been given the LCM of A and C, we can equate this to our expression to find the unknown values of P and Q. So that means that 2 to the power of P is equal to 2 to the power of 4. And as we have the same base, it means that the powers are equal, and therefore P is equal to 4. And 5 to the power of Q is equal to 5 squared, and therefore Q is equal to 2. All right, so R is equal to 1, P is equal to 4, and Q is equal to 2. That's it for this tutorial. Keep up the good work, and I will see you soon. If you like this video, please give us a thumbs up, leave your comments down below, and subscribe to this channel so you'll be the first to know when we release our next videos.